Hello everyone. In this video, we will be solving system of equations using equal values method. This is the fourth part. I will put the link of the first, second, and third part in the description box below. We have some steps in order that we can solve this system of equation right here using the equal values method. The first step is to isolate a common variable or expression to one side of the equation. Usually it's going to be on the left side. And just by looking at this y plus 2 squared is common to both of them. So that means we are going to isolate this on the left side for this first equation and isolate this for the left side on this second equation. So let's have the first equation. Again, since both of them have y plus 2 squared as common to each of them, we are going to isolate this on one side. So then we go ahead and subtract x squared from both sides minus x squared. So then we go ahead and rewrite this as, that's going to be y plus 2 squared is equal to 25 minus x squared. Now, others are going to say that, oh, that should be 25 minus x squared. So that's going to be 24x squared. No. Remember, these two are unlike terms. This one doesn't have an x squared. This one is an x squared. So they are not like terms, so we cannot subtract them. So this will be the equation that would come out. Y plus 2 that's going to be squared is equal to 25 minus x squared. Now let's work on the second equation so that we have y plus 2 squared as the one that is isolated on the left side. So I'm going to have the second equation right here. So I'm just going to rewrite this. Okay, so in this problem here, we want y plus 2 squared isolated on one side. So we go ahead and add 5 to both sides plus 5. So then we go ahead and cross the 5 out. So we're left with y plus 2 squared is equal to x plus 5. Again, others are going to say, oh, that should be 6x. Again, they are not like terms, so we don't subtract or add them together, so we just keep it as x plus 5. So that means these are two separate terms since they are not like terms. So then we go ahead and rewrite this to its equivalent equation. Y plus 2 squared is equal to x plus 5. So these two equations are actually equivalent equation, meaning they're just the same. We just had to isolate common expression or this common expression that we have here on the left side. So I have prepared here this card right here. What I'm going to do is, since we know that this two purple cards are equal to y plus 2 squared, they're equal, they're the same, using the equal values method, that means these two are equal to each other since both of them are equal to y plus 2. So then we can go ahead and say that this x plus 5 and 25 minus x squared are actually equal to each other. So that means these two right here are equal to each other. So then we can go ahead and write the equation that we have up here. So that would be So what I did was I equal them to each other. So others are going to say, oh, but you switched it around. It doesn't really matter. You can switch this around. They're still equal. So then we go ahead and use this equation that we have here to solve for x, which is the second step. Use the equal values method to solve for the first variable. So the first variable that we can solve would be x. So working on this, we want to use the zero product property for this. So then we go ahead and leave one side equal to 0. Since this is a negative x squared, we want a positive x squared. So we're adding x squared to both sides. So this would be plus x squared, then plus x squared. So then we go ahead and cross this out. We're left with 25 equals x squared plus x plus 5. Now, please remember, others are going to say, oh, that should be a 2x squared because there's an x and an x squared. Again, these are unlike terms, which means we cannot add them together. So there are separate terms here. So we started with the highest exponent, x squared plus x plus 5. We want to use the zero product property. That means we wanted the left side to be equal to 0. So then we go ahead and subtract 25 from both sides, minus 25. So then we are left with 0 is equal to x squared plus x, that's minus 20. So then we go ahead and use the area model in order that we can determine the factors for this one. I'm going to show the area model up here. Okay, so the factors that we got using the box and diamond would be, that is gonna be x plus 5 times x minus 4. So then from here, we use the zero product property to solve for x. So this would equal to first x is negative 5. So this is our first value of x. So I'm just gonna put this inside the box. So that's the first x. The second x would come from here. So x is equal to positive 4. So this is our second value of x. So we already have solved the x. We're now ready to move on to the third step. Plug in the values that we have solved from step 2 to any of the original equations or to any of the equivalent equations to solve for the other variable. So I'm just gonna write the next step right here. So what are we gonna do is we let x is equal to, let's take the first one, negative 5. So then we can use any of these two. It can be the original equation or the equivalent equation. It doesn't really matter because these two are equivalent to each other. So let's just use this equation right here. So what we would use would be this one. So we're gonna use this in order to solve for y, since we already have the x. So then if we set that up, that would be y plus 2 squared is equal to x plus 5. So then our x was negative 5, so we plug that in there. So that would be y plus 2 squared is equal to the x plus 5. Again, our x that we have here was negative 5. So then we do the math here. So this would be y plus 2 squared is equal to 0. So then we want to solve for y because we already have the x. So then we go ahead and square root both sides. So we cross the square root and squared. So we are left with y plus 2 equals 0. So 0 doesn't have a positive, we don't have a positive 0, we don't have a negative 0, so we just keep that as 0. So then the first y would be, we subtract 2 from both sides, minus 2, so then we go ahead and come up with y is equal to negative 2. So this is our first value of y. Now, I am going to write on the side here the points of intersection. Now, please remember that the point of intersection is actually the solution to this system of equation. In a graph, this means that these are the points where the two curves that we have here are touching each other, or these are the points, or these are the values of x and y that makes this equation true. So then the first point of intersection that we have here would be our x is negative 5 and our y is negative 2. So this is our first point of intersection. Now let's move on to, we're done with the x is equal to negative 5. Let's move on to x is equal to 4. So I'm just going to show that up here. So we let x is equal to 4. And again, we're using this equation right there. So then we go ahead and rewrite that. So we plug in the 4. So then we go ahead and do the math. That would be y plus 2 squared is equal to 9, because you have a 4 plus 5 is 9. So then we go ahead and square root both sides. Now please remember that we are going to use the square root property for this. So the square root property states that if we are going to determine, so if we're given x squared is equal to a and we want to solve for x, we square root both sides and then we say that x is equal to plus minus square root of a. So in this problem that we have here, if we square root both sides, so then we can go ahead and say that so we can cross the square root and squared. So we're left with y plus 2 is equal to plus minus square root of 9, which is 3. So pretty much we have two equations here. So the first equation would be y plus 2 equals positive 3. And the other one would be y plus 2 equals negative 3. Now others are going to say, where did you get the plus 3 and the minus 3? Remember, the square root of 9 is 3, and so we have two values. We have positive square root of 9 and the negative square root of 9. So we have the first value is the positive square root of 9, which is positive 3, and the second value is the negative square root of 9, which is the negative 3. And then from here we go ahead and solve for y. Y is equal to 1. So the next point of intersection when x is 4, so I can write that up here. When x is 4, our y is 1. So this is the second point of intersection. Now let's move on to the third point of intersection from here. Y is equal to negative 5. So this means that the third point of intersection would be x is 4. So I'm just going to write 4 right there. And then the y is negative 5. So this is our third point of intersection. On the side, you will see the Desmos version of this problem. We can say that the point of intersection, or the points where these two graphs are touching each other, is at negative 5, negative 2, 4, 1, 4, and negative 5. That's it. If you find this video helpful, hit like and subscribe for more math videos. See ya!